Test.
So that's it.
All right, that works.
Thank you very much.
So you can take the seat. No, this is just for the laptop. You can take that seat.
What is that?
Go ahead, have
Oh,
a seat,
okay.
please.
I was just.
I'm not sure what
It's
that
like
is.
to live stream. So if people can say, like they can see this later.
Yeah.
Yeah.
You have to put this here.
Yeah, that'll be.
Oh, this is you are recording the
Yes.
session. Oh, then I wouldn't want to sit here. I wouldn't want to be the first.
We're not going to appear.
You're not going to be.
It's just us here,
that
right?
Yeah, it's just us and
Oh, it's facing that.
It's facing
camera
this
is
way,
on
yeah.
there on that side. So the camera is facing this way.
I can see where it's going, but
Oh, okay.
it's shooting at kind of low.
No, we can, just wait over here.
I don't think that would help
No,
anything.
no, not really.
It's
Oh, he's going to
shooting.
get a booth over there.
Oh,
That's the place, right? Get a booth.
Good place to find a book.
thank you.
You're going to share here, you're going to-
Which side are you gonna stay on?
Both of them.
So yeah, there's a chair right
It's gonna be tough.
there.
Yeah, it's pretty tough.
Unless you use the podium. 'Cause I don't know how much you can move that. This over here.
Beautiful, that's great.
Good height. I'll just stand here and hold it. Just kidding.
Yeah.
Good?
It's like Star Wars.
Yeah.
It'd be like Star Wars
Star Wars?
with that perspective.
That's good.
So cool.
Good, cool.
You want to use this?
No. Yeah, I have good news. I'm not going to travel anymore.
Really?
I canceled the trip.
Well, I mean, I don't know if it's good or bad. Might be a personal trip, right?
It was a vacation to Thailand, so
Well, I mean, that's
it's
like
not good.
right?
It's not good to cancel. But that's like, I'm sorry. I have a lot of things going on. I cannot afford to join there. Yes? Yes.
So,
No, we haven't started.
okay, fine.
Yes, I'm waiting for some support to some people coming. And I'm pretty happy that it's going to cool.
I mean, that's a good point. It's really tight. It's at a -1. I think I'm back.
Yes.
Oh.
Yeah. So, should I stay there?
That's recording, so if you're saying it
Yeah.
more, like-
I think you got a full class.
Yes.
Maybe I'll cruise. Thank you.
Thank you.
for
Thank
sending
you very
me.
much for
You bet.
the.
I didn't realize. Very popular.
This is the first class. If you want to join us,
Yeah,
Thank you. Thank you.
it's
What is it?
natural language processing or artificial intelligence, grab information from texts to drive knowledge from texts. So
Algorithms.
algorithms. Idea? Is it good? I like it.
Excellent. Well,
I think it's going to be cool. I'm suspicious to say.
You have a lot of interest. I've not seen a class this big yet. I should move over there. I want to give people room.
Thank you very much.
You bet.
Sir?
There.
Yeah.
really nice, yeah.
Are you guys with a company or?
No. Actually,
Yeah.
well, let's present ourselves. Let's start.
Yeah, I think it's good. That's right.
So, hello, hi everyone. Thank you very much for coming. And it's pretty satisfying to see a cool class. It's pretty cool. So my name is Vinicius. I'm one of the deans of the School of AI. So the School of AI is a project that starts with there's this YouTuber, AI YouTuber called Suraj Raval, and he started to have a lot of demands of videos and contents, etc. And he said, okay, let's start this movement called School of AI. What is the goal of this school? Is to give knowledge, AI knowledge, for those who aren't who doesn't have computer science background or know to code a lot. So what does this mean? This means that we want to give this power, the power of AI, to the hands of everyone in a very simple way. So you can drive knowledge, you can drive information for your daily lives. So please. So this is Kasia.
Yep, I'm Kasher Morale, a high school student nearby in West Windsor, and I'm one of the co-deans along with Vinicius. And as you said, we're promoting this concept, like as part of Suraj Raval, of democratizing AI. So people know best, like whatever industries they're in, whatever jobs they're doing, where they can apply AI, and we want to enable these people to be able to apply this, this wonderful knowledge into their use cases in their real life.
Okay, so we are starting today this series on natural language processing. This is a 4-course series and then we are going on March, April, we're going to have a computer vision class as well, 4 classes. And we always end up with a capstone project. So what is our goal here? We are going to give you the first start to use natural language processing, grab data from interesting sources. In our case, today, we're going to use Twitter. So I have a class here that we are going to, you just type a keyword, and then you're going to receive a bunch of tweets regarding that debate. And then you can assess the debate somehow. Now, I work in a company that does AI. I have a company that does this, and usually what I do is for my clients, their consumers, I check the consumer reviews, and I use natural language processing to do that. So that's one of the business implementations that we're going to see today, but in a very high level. But you're from here, you will have the knowledge to go deeper, to drive the knowledge that you want to apply into your case. So as you can imagine, the text from different cases varies a lot. Or if you are in a research field, if you go to Google Scholar, and maybe do your research, you're going to have a bunch of information that you can filter out. But the way that you're going to filter, the way that you're going to drive this knowledge is different from my case, which I work with consumers, consumer reviews, for example. So this is a general purpose tool that you're going to fit into your case.
And adding on to Vinicius, like whatever we're doing in a hands-on perspective. There's theory, there's like the mathematical foundations, and that's wonderful. But also we're trying to apply this to actual business use cases. So we want to get that hands-on touch, and you're creating your own AI application with your own data and your own stuff. And as I said, we're ending up with the capstone project, which is primarily like research oriented from your own end. So yeah, that's how we're always gonna code.
So natural language processing is something that is being researched. So it's a very hot field. So we can go as deep as anyone wants, because this is Jan Kuhn who researches this. Although he's good on computer vision, but yes. So I'm sorry. Now there's a second thing that I believe that we have a very how do you say this, a different level of skills regarding coding, regarding understanding of what natural language processing is. So first, who here has done anything regarding natural language processing? Okay, all right. So you are in the right class. Coding. Who doesn't have much knowledge on coding? Okay, this is going to be. I try to make this as easy as possible. And all right, what else?
And the language for the people who are not so familiar with coding, the language we're using is like really it's really close to English language itself, so it's not like super complicated. And the stuff that you see is pretty much the stuff that you get. So it'll be pretty easy to pick up and use for the applications that we're building.
Okay, so shall we?
Yeah, let's get started.
Any questions beforehand? Any comments?
Would you like to ask a question, which one at the end?
Oh, no, please. Come on. This is the goal here. We're going to code together. So there's a first sentence that I inputted. I'm going to ask you to input other sentences and check the results. So it's
Interactive.
It's interactive. So
Python?
Python. Yeah. So first, let's start with the setup here. Instead of setting up an environment for everyone, Joe here gave this fantastic idea of just please type here in Google Colab. School of Art and okay, yes. And here you're going to have a new Python 3 notebook. So what is the best thing about this?
Colab.
Okay, Colab, Google Colab. The best thing about this environment is that almost everything is already installed. So we are not going through that phase that, oh, mine is not running, everything runs here. And in the end, you just download the script. Okay, so
it's on the cloud too with your Google account, so you just log in from like any computer and device, you just find it and you can run it.
Does anyone here doesn't have a Google account? Does anybody here is uncomfortable of using your own Google account on this? Okay, we created a Google account just for this class, if this was the case. All right, so is everybody here on the same page?
You want to log in with our personal account? Google account?
If you do have, if you don't mind logging with your account.
Sorry?
How do we get onto that page?
Yeah, you're on the page, you just want to click sign in. Just log into your Google, log into your own Google account.
No, but what's the class Google account?
No. If you want, you can create one Google account.
Oh no, there's a Google account for the class if you want to input there.
What's the Google account?
Princeton School of AI altogether @gmail.com.
Princeton. Write it.
School of AI.
Yeah, marker or something. that
Yes.
Yeah.
Kelsey
Gmail.
@gmail.com.
you can- Yeah,
You have a marker?
that we can use.
No,
Like on the whiteboard.
And the password is Princeton with capital P.
I'll get someone a little more.
Princeton. 01, period. That's the password. And log in. Princeton. Oh, that's not very good. Princeton School
Just give me a black marker so it's more.
of AI. Okay. So, is it good?
It's Princeton 01.
That's what I wrote.
01. 01.
Princeton School of AI.
01.
Yeah.
Here's the password.
And what's the website?
Period. I'm sorry. Login is Princeton School of AI at gmail.com.
And
Password.
I tried that.
Oh, thank you very much.
Oh, 01.
No? Oh, sorry.
No, enter
So-
your wrong password.
Princeton, can you? So log in, Princeton School of AI at gmail.com.
School of AI at gmail.com. Enter your password.
Did anyone log in? Yes, it works? Okay. Are you here? Oh, Google Colab. File.
Yeah.
File.
Can we use our own?
New-
Yeah, you can use your own Gmail. If you're not.
You can use your own Gmail.
I logged in with my account, but how do I go to this page?
Now let's go to Google Colab,
We're there.
Yeah, I'm there already.
and then you go to File,
You can log in from a file.
Okay.
and then you put a new IPython notebook. Or new Python 3.
3, okay.
Python 3 notebook.
We'll have our own files, not that file.
Trying to find my Google Drive.
Okay.
I can't.
Now, the second thing to set up is open a new tab, go to princetonlibrary.org. And if you scroll down, come here in artificial intelligence. And here is going to have a link for my IPython notebook. If you click, you should enter my IPython notebook. I've created two, it works. So
Okay.
that's like the engineering, how to demonstrate something to layer.
Is it because somebody else was talking?
Where's this one?
Yes, go to princetonlibrary.org. If you scroll down, you're going to have the NLP class link.
Then this link.
Yeah, if you want to show the libraries.
Yes.
Looks like,
So just, yes, princetonlibrary.org. That's the first thing.
Oh, Scroll goes upside down.
If you scroll down,
That's the Windows.
I know, same thing.
you have here this link. You click here, don't click, I'm sorry. You have this link. If you click here, you're going to have a link below that directs to the NLP class notebook.
It's a summary of the course, and you can. It's like.
In the end, you're going to have this.
All right.
Okay, so everybody, what happened?
Log into your account.
You're not.
I'm having trouble getting into the account.
Okay, Kesha,
Yeah.
can you start talking?
Going the other way.
All right, so the first thing that you have over here is you're going to have the imports for your. You're going to import your necessary libraries. So what are libraries? Libraries are a piece of code. You can't create everything when you're writing programs. So you're going to have to import some primary knowledge so you can build off of it. So we have Spacey, which is like our NLP notebook. NLP library where we can just, create, use functions that they already have. Tweetbee, it's like your Twitter thing API, which is going to be really fun and interesting that we're going to go over a bit later. And this is like the other basic, like fundamental stuff in order to display your text, in order to have the data, in order to like train your models and stuff like that. But you'll find this at the link, and it's just boilerplate stuff that we need in order to run our code. So it's like your foundations. Yep.
All right.
So
So this is the
over
code
here,
that we're going through.
any questions so
And
far
this
on the
is your
importance and
code.
stuff like that?
Oh, okay.
EN on?
Sorry, what is that?
Oh,
And, or you can simply copy and paste, but
Oh,
please.
It's PrincetonLibrary.org, and then you go to events,
why you couldn't make it?
I don't know.
and then you click this one, and then you go down. And sorry, you had a question.
Yeah, what's EN core web?
So that's like your package. So in Spacey, you have different packages that are trained models. Like you can either get like a huge bunch of text and train your own model, or use something that has been pre-trained that we're going to build off of. So that's since we don't have the time to train it, we just use this one. Anyway, so
Okay. So look, you can either copy and paste from one tab to other, but please do not delete because I think it's going to mess up with mine here. Okay, just copy, Control C or no, Command C on Mac, not Command X or Command Z as well. It's not going to be very good. Okay, so let me go through the packages. Of course, Spacey, that's the NLP package that we're going to use. There's another very famous package on Python called NLTK, but this is simpler, this is better, faster.
it's actually shown that on some tests, this thing is in like tokenizing, which is cutting down a sentence into words. It's 443 times faster than like NLTK, and therefore, like we want to use the modern stuff because we won't really use a slower application in the business world. So that's why we chose this application.
TweetPy, we're going to use this to enter Twitter, grab the tweets, and get the data and work with it. RE, we're not going to use here, but this is for regular expressions. Whenever you're trying to deal with texts, you have to use this one. We're not going to use this in this case. Now, EN Core Web SM. So this is a pre-trained, I think I should.
Yeah, I explained this. It's a pre-trained model because like we don't have the time and resources to just train off an entire dictionary. So like, you see the SM, and then you see the LG. So basically, SM is for small, LG is for large. There's also an MD, which is medium. Depends on different sizes. Obviously, the speeds will be different. Like a bigger model is more time in order to run commands and stuff like that. But we chose for a small one because it works for a demo right now and it's quick and fast.
But if you want to use this professionally, uses the LG because you have it's wider and it has more nuances, capture more nuances. So pandas, this data frame, everybody knows pandas. Word cloud, so we're going to build some.
I think we should go over pandas real quick because
Yes.
like it's our data processing library. So if it's like the go-to data processing library, if you want to have data and like read it, and so it's like an Excel sheet, right? There's this thing called common separated values, etc., like an Excel sheet. In order to read that stuff, you need a really good, reliable library, which is fast on this numerical computation stuff. And that's where Pandas comes in. It's a really good data reading library, and it's very useful in most modern business applications.
Word cloud, we are going to build beautiful visualizations. Beautiful visualizations, which, in my experience, it's what sells where the value added is. Whenever you're charging a lot of money, they want to see nice graphs. This word cloud is very good for that. Text blob, I'm going to tell later, it is better than Spacey for sentiment analysis that we're going to cover here as well. And finally, Displacey is to display Spacey visualizations that we're going to see soon. Percentage matplotlib inline, this shows the plots in the Jupyter notebook instead of opening a pop-up and showing in another place.
And one thing, if y'all could do, sorry, but it's just that when you're running this, like if you could just copy this and like put it in your own untitled notebook, like you know how we created one over here, It's like
Command C, guys, please.
file new Python 3 notebook. If you could do it over there, because this is like on the live runtime, which is right here. So if you could do it separately, it'll be like really useful.
I think.
Yeah, copy on
So
the.
print
I think the
out
fastest way to do it
the
would,
screen.
instead of cutting and pasting each one, just to copy the notebook to your own notebook.
Could you
Yeah,
just print out this?
So a way to do that?
Yeah, make a copy of the
So we
Take a
have
copy.
to copy
Yeah,
it.
and then work on that, and then work on
Sure,
that.
we'll do it next class, and we'll definitely print out like a summary, like a guided list sheet.
Because it's easier, we don't have to switch
You
between
know, I
windows.
got the whole, you know.
Okay,
But then everybody's going to work on this?
gotcha. So you want to print this notebook
Yeah, just print this. So we
right
don't-
now?
But is everybody going to
I'll-
be working on the
I'll-
same? Oh, people can copy.
There's copy the whole IPYN file. Go to files.
I'm gonna drive the next year.
And you can, save copy and drive.
Okay, that's great. So guys, just go File, Save a Copy in Drive. And it's going to pop up a new IPython notebook just for you.
Just rename it,
Oh, here,
You don't even have to rename it.
you know.
underneath,
Right.
not that menu.
So first of
See
all,
file underneath,
I don't see Python.
Save,
no,
save pages.
no, different menu,
You were.
down here.
Is this
yours?
See, that menu, right
Oh,
here,
here.
oh, right there.
Oh, no.
Yep, file, save copy on,
File,
drive,
Copy. Oh,
and drive.
Save Copy in Drive.
Oh.
Okay,
I don't know.
so is everybody on the same page here?
No.
Okay,
Green button right here.
so let's rock. Fine. So,
Maybe I
Okay.
should put-
all right,
I
so
need to put
Yeah,
it-
open
what's the
tab.
goal of natural language
That's what I
processing?
do.
For the
Automatic.
computer, you could just
See,
read
it says it's a copy.
the words itself. But what this
Just the name.
Spacey does, we're going to
Zero,
call
zero.
this model that is already
To run it,
trained.
just
We are
go
going to
there.
call this guy NLP,
To run that.
okay? And then we're going to say, okay, NLP, this thing here, this text. What this will render? Actually, it's going to understand that each thing here is one token. It's going to call this, each thing is one token. And this pre-trained model will understand the relation between those tokens. So here we are printing the tokens. So you see the period is one token, the link is one token. And whenever we say the display C render doc1 style ant Jupyter equals true, this appears. So instead of just looking at each word and understanding this is a word, actually it understands the relation between the words. So this model understood.
It's right there.
Yes. So instead of going only through words, it understands the relation between the words and understands the entities. So it understood that this here is an organization. Now, whenever we run the model large, it understands that this is a place and this is an organization. So can you?
Yeah, sure. One thing that I would like to mention, as humans, we know like, oh, awesome, dot, enter another word, blah, blah, blah. But this is actually proof of the machine, the model that is being trained, because it can separate these words. Like if you think about it, at the end of the day, it's binary, but like splitting that binary into different pieces is some like just some of the stuff that that's basic into. And adding on to the entity thing, so ENT, so there are multiple entities. Like, so you have your geopolitical entities, like that's what he talked about the large model could do. And then you have your organizations, your money. Like, so this model has like, I think around just 5 or 6 or 7 entities that are already pre-trained that it identifies within a sentence. And like you said, the bigger the model, the more entities currently.
If it is a currency or not, it grabs these kind of nuances.
So what is going on in the NCore web SN?
We're
What's it
loading.
do? Is that your core library?
It's not a library, it's our pre-trained model.
It's a whole model. And actually, in the third class, we are going through this word2vec,
Yeah.
which would be the core of natural language processing. given we thought about doing this on the third class, because given the goal here, that is to empower you to use this, we say, okay, let's put this as given. But very quickly, word to vec, it transforms words into vectors. We're going to enter this later, actually. But each word is placed inside a context. So for different contexts, each word will have a different vector. The same word will have different vectors. I'm going to show this soon.
We're showing this a bit later, but like each word has like it's like linked. There are links association to it. Like each word is translated in numbers as like a vector. And we're going to go over this in detail, but the associations are trained by the model. So it looks at the context. Like, how do you know what a word means? Like that you don't like a new word. You look at the context. Well, what does the context look like? So that's what we're going to cover.
Okay, so is this similar to word to vec?
Yes.
Does it say it does the same
It's like a
thing?
trained.
So it vectorizes the words.
Yes. I'm going to enter it. Please.
So you chose a pre-trained model. How do you know that model is appropriate for the content that you're going to be looking at?
It's a general purpose model. This stuff like
Yes.
the spacey models are general purpose, SM, MD, and LG. But obviously, you're
But you
100%
can
right.
train your own model. Spacey leaves. We're going to show this in the third class. The third class is going to be more technical. Let's change the model. Let's put our features on that. So in our case, let's do this.
So you said generalized. What is it? What was it trained on?
It trained on Wikipedia, for example. Wikipedia text. So grab the whole Wikipedia text and train on that.
So why did you go with this instead of word to vec? Word to vec is pretty popular.
Word to vec is popular, but for the ease of use right now, we would like to use Spacey because first of all, like it's easier to get started with Spacey, and second of all, these word to vec you can train your own associations and entities, but this is already pre-trained for us to use, which is a bit faster.
It's much simpler. So and I think that the goal of the class would be to go this way.
Is this where we can see the list of models and then what do they do?
Yep, you can go to spacey.io, and it has like models, usage, and so you see usage over here. It's like, whoa, Spacey can do this, that. It's a picture, blah, blah, blah. Like, you can explore this on your own time, but the whole idea is that Spacey, it has a bunch of functions and models that you can use. Like, it has actually in a bunch of different languages as well. Like,
I use in Portuguese.
Yeah, he uses in Portuguese. There's French, Italian, Danish, stuff like that. Anyway,
cool.
So,
okay. Yes.
Spacey to download that EN core web.
Yes. When you do when you install in your machine, you're going to pip install. You're going to pip something load.
Yes. In this case, you download in English.
Yes. Yes, but you can,
download other languages.
Other languages.
With Spacey.
Yeah.
But you need Spacey and the other library to run this.
Yes.
Is there any fuzzy matching in these libraries for the tokens? It's matching tokens and stuff like that, or is it just complete matches?
I think he's saying like the cluster. Are you talking about like the clusters of words? There'd be multiple clusters of. It sounds like one word is directed to one thing. Yeah, that's true. We're gonna we have actually a really cool demonstration for that, which shows it in like a 3D space how the words are modeled. So at the end of the day, the words become numbers. How do these numbers portray in relation to other numbers, which are other words? And we'll show that on. It's actually something created by Google. If you may have heard it, it's called TensorFlow. It created a demonstration.
But let's go through. Let's go to the third.
So
this So each word is a token. It understands as a token, and actually each word has its properties, has its attributes. Now, if you go lower, okay, when we do this, this shows the relation that. Can you zoom out a little bit?
Yeah, sure.
So this understands the relation of the words in a sentence.
Yeah.
So when the model already understood the relation of the words.
So you are entering Princeton Public Library. Like enter is related to Princeton Public Library. The library, libraries, it's Princeton's library and it's a public library. So it's called a dependency parser. And you look at how these different words are dependent on each other. And all this information is not something that we trained, but it's something that Spacey had in its own SM, like small model that we ran.
I think that. Right. Okay, so so each token, so let's grab MJ as our first example here to see the properties of each token. So MJ, you have this int type, which would be organization. If we were to use the bigger model, this would recognize as a state, actually, a geographical GPE. A second very important thing that each word has as a property is if it is a stop word. What are stop words? Are those words that doesn't render a lot of value to the text. So for example, is doesn't give meaning to the text. This is bad. Which is the word that gives more meaning to this sentence? This is bad. Which one? Bad. So this and this, you don't care. So basically those. So you have pre-installed stop words, and
it's down here. All these.
Okay, so those are all the stop words that is already embedded. Now, there are some stop words. For a given case, you might want this not to be a stop word. Maybe in your case, it is an important word. So actually, you can put this. You can say, okay, this is not a stop word. In our case, we put it token. Okay, so token example is not a stop word. Can you go down a little bit? All right. Test. Test is not a stop word. So I said, but I want test to be a stop word. Now test it is. So you can put this command here, NLP.vocab. You put the word that you want to be a stop word. You assign this, and it understands that now this is a stop word. Why does this matter? Because whenever you are searching, for example, we're going to use this for a Twitter. You're going to search for a keyword. Let's say we're going to use wall. Of course, wall is going to appear in every single tweet because you are searching for that. Now you want wall to be a stop word. You don't want wall to be. You want to drive knowledge from that information. So you're going to get rid of wall and just see what each tweet says. Okay, make sense? Right.
And the thing is, sometimes, as Vinesh has already mentioned, stop words, you don't want to remove some of the stop words, right? Like sometimes they actually do in fact add context, and that's like purely based on as you go. Like right now for basics, we're like just taking away stop words, making the sentences a bit more basic or learn the associations. But like maybe you have to deploy like some NLP model, like a word vector. Now over there, you want to like maybe adding a stop word can help with the context. You know, it's like it's purely to do with the context. More times than not, it probably would help at this point in your lessons. But in the future, if you wanted, I wanted to like get a better model, then you can try with stop words. There's no harm in trying it and see how the results pan out.
So just leaving this aside a little bit, actually talking about business implementation. Yes, please.
Oh, yes, sorry. So when you do this, is stop, does it add to the dictionary or is it locally?
No. This I'm checking if it is a stop word. Actually, I add with this here. Oh, but is stop equals true.
So does it go into part of the dictionary
Yes.
of all those words? So you can manually add more than what's
Yes.
Okay.
Yes. And
Test is now a stop
remove.
word. Test is a stop word now.
Yes, please.
So my understanding of stop word is something that's not very interesting, so you're filtering it out.
Yes, I'm filtering.
I know I spelled stop word, but for whatever reason, like it's going to come up at the top.
Yes. Yes, that's perfect. So regarding a business implementation, you see that you always need someone who understands the business together with a data science, an NLP person. Because if the NLP person doesn't know what are the important words, what are the important features, they just know a bunch of code. So that's why we like our work to teach this, because actually the main information that you have whenever you're using AI to bring in some solution, the main input is the domain knowledge. So being able to be very good at your job and also know a little bit about programming. This is better for AI than just to know a lot of AI. Okay, merchandise is apart. Let's go. Yeah, so okay, each token is represented by a vector. Now, the size of the vector is going to differ. Now, so each word, the computer thinks as a matrices. The computer thinks in numbers. So we have to pass text. We have to give numbers to those texts. So that's what is showing here. So we have the one example token. I put it here, the vector, just the 10 first elements of the vector, but actually there are 384 elements. Each word is a vector of 384 elements.
And I'd like to build off of this concept a bit. As we can, so we see in like what, maximum of 3 dimensions. So now imagine there's this plane here, right? Just a 2D plane. One word could be here, one word could be, so car, motorcycle, and I don't know, limousine. And then there's like, bird, dog, cat. So this is a 2D plane of thinking. And then and the more complex you go with the words, like in most business applications, probably never 2D. So the more complex you go, you have like this 3D, and then you have these stuff. But now you have n dimension, which is, as I said, 384. So it's like huge. It's really not possible to think about that stuff, but that much complexity is needed to understand the relationships between words, because it's really not as simple as like cat, dog, bird, or whatever I said earlier.
384 is fixed or is it minimum maximum?
You can set like whatever dimensions you want based on how much data you're training for and how much complexity you want.
If you're building your own model.
Yeah, in this case we're using spacey stuff, so it already said its own like 384. They set these dimensions and the number of words they're training on like prior, but this is something you can change. As he mentioned in Word2Vec, we can change the number of dimensions that you're using.
Is the dimension the context?
Dimension is like, so the words are actually embedded. It's called a word embedding. So the dimensions are where exactly the word is embedded in relation to other words. So it's not really the context, but it helps show how words can be similar to each other.
Yes, it brings the idea. I assume they're similar to the stop words. There's some sort of synonym.
Not on spacey. If you use NLTK, there's a synonym. But here we have similar words. So there's a you put the word, the text. Actually, we have this a little bit also, but you have the level of similarity. Why? Because once we are in a matrix, you can do vector distance, vectorial distance, and now you can check if you have a given word here. You have this and this; they are very similar. This and this, they are not similar. Why? Because we went from text to a vector. Does everybody understands what I'm saying regarding distance, vector distance, or not?
The closer the word is, the more similar the word is. Dog and cat, really, really close, right? Okay, so computers, you don't use text, you use numbers. Now the numbers, as I said earlier, it's a word embedding. The closer you are, so it's like in clusters. It's like a bunch of words. Oh, there's like dog, cat, like different species of dogs, right? Like golden retriever, German shepherd, etc. That'll be in like one cluster. They're similarly related words. They're together, but in a completely different clusters, like engine parts, right? Like the transmission, the gearbox, or whatnot. That's in a different category. So in order to represent the association between these words, we want to translate them into numbers and find how similar and close. You can think of these as coordinates. Right, so for your 2D one, this would be like, instead of 384, it would be like 2. If you're thinking about 3D one, instead of 384, it would be 3. So as a coordinates, how do you embed these words in relation to each other? That's what's going on.
So the angle between vectors?
It's not the angle, it's this Euclidean distance, the distance between each.
Yes. Within the spacey model, each word would typically have the same numbers, or it depends on the program?
Wait, I don't know.
The numbers associated with the given word,
right?
In the spacey model will always be same, or they are dynamically.
In this model, it'll be same because it's pre-trained, okay. But in something that we're training, it'll be different because we have different words and different dimensions and whatnot.
So the words, whenever you put the word, it grabs. What does a Word2Vec does? Actually, you have the word that you want to assess. You put M to one side, M to another side. M is the number of of words to one side and to the other side that you think it relates to that word. And then you go through a huge text like Wikipedia and grabs every single time this word appears. Grab the words next to it, the other words next to it, and this model will render the context that these words appear. And once you do that, whenever you input some sentence, whenever you grab the word, I'm grabbing blue. So I have two sentences. The meaning of blue is different. So the vector of the blue is going to be different because the context is different. Here I grab just the first element of the 384 just to show that this is different.
So it's the same word, but the surroundings of the word are different. I'm feeling blue versus the sky is blue. It's like the context, the model understands the context is fundamentally different. In that case, therefore, it's given different coordinates. And like it's like, as I said earlier, it's a coordinate system. So if X, Y, Z, now A, B, C, D, E, F, G, like the dimensions are endless. And like, I think it actually goes up to thousands of dimensions when you're treating like a really, really big problem.
Yes.
Yeah, so I have a question. So here on your vector, you have this negative 1.34, and then you have like 2 points. So just briefly, I guess, how are those numbers calculated? Are they like some squared error or?
It is a probability. It is given the context, the probability of the word appearing, or is the opposite.
Like
but we're going to on the class number 3, we're going through that.
Okay, thanks.
So these numbers are actually codes, right? Not the numeric value. Right? Is it processed as a numeric value as well for clustering purpose and things like that?
It's a coordinate. So like
it's a coordinate. It's a coordinate.
From the pre-trained model, the 384 is the total number of features extracted from the pre-trained model, or is it just for your input string?
No. Actually, you have all the words. Let's say you have 70,000 words. What the model will do is for each word, they're going to assign one vector with a bunch of numbers, 1.2 minus 3.5, so 380, 4.3. Each word will have a vector. And from this, you can grab some similarities.
It's not a feature?
Those are not features. It's just a representation. Instead of representing with a blue, instead of representing blue with a B, U, L, U, and E, the computer doesn't understand this. But the computer understands the vector that represents blue.
So every word is represented with 384.
Yes.
Yeah, 384 coordinate. Or like X, Y, Z, like how X, Y is 2, it's like 384 of those.
So
it's not like one-hot encoding.
No. One-hot encoding is the simplest model. But actually, the first thing that you input the neural net, depending, I don't know if space is trained like this, but probably is one-hot encoding. And then it puts the vector of the context, and then deep learning. And
for those who don't know, one-hot encoding, if I was given a sentence like, I am blue, actually, I am feeling blue because I am cool. Like, is that okay?
Okay.
So, okay, this is a sentence. Now we have 8, like an array of or vector of like 8 spaces, right? And now each word is like, it becomes a 1. So if I am feeling blue and I am cool, the I, like the 1 will become a 1, and the I, like I am feeling blue and I am cool, that'll also become a 1. Each word is given its own digit, like a switch, like you flip switches. Each word has a switch, you flip them like on, oh, that means the word is there. You flip them off, means the word is not there. That's what one-hot encoding is. It's like a really, really fundamental way of how to represent these numbers. That's what we're doing in word vectors and spaces trained models.
So isn't this conceptually what you're trying to do is to take some data matrix that you created, like a one-hot encoding or
right.
item turn matrix.
Yep.
It's very sparse, has only zeros and very few ones.
Yep.
And you want to reduce the dimensionality in some way.
Yep.
So that you can represent it in more compact space. And by doing that, those words that are strong, I don't know if it's on the rows in the column, but are going to, you're going to create these dimensions, factors, those things are like how related each item or term is to that dimension.
Oh, these are very good. But click here, Lesha. Let's see the This will show this.
This is exactly what we're talking about. Like, this is using what he said about a dimensionality reduction algorithm. So don't worry about that too much. But these word clusters in a 3D space, like these are all like the blue word is like they're all really, really close to each other. And
So now computer is also
Word to
feeling
fact.
blue, right?
sorry.
Your program is also feeling blue.
Now this point here, the PCAs, the component, the principal components. So we have a huge matrix. You can imagine that it's a huge matrix of a bunch of words and the value that these words appears. Now what we're going to do, we are going to reduce this dimensionality using one thing called PCA, Principal Component Analysis. To show this here, we have to do that. So again, let me rephrase a little bit.
384 to 3. That's what it is.
Yes, perfect. So I have 10,000 words. So you have 10,000 by 383. What do? You're going to reduce for 3 components using PCA. And then you show here. The problem of PCA is you have to check the total variance described. Variance is information. So you have the whole matrix, you have information on there. The variance is what gives value to the information. Whenever you reduce, PCA is a very good technique to try to put as much variance in the first principal component, then as much variance on the second, and so on. In this case, it only grabs 8.5% of all the information. So in this case, the PCA is not the best way to go. That's why deep learning is much better. Yes.
Yeah, so you have a lot of words, 385, 86, right? So
Not words.
No, those are dimensions.
Dimension of the words.
dimensions also will be your features.
No,
Dimensions.
it's a place where we put in the space.
So dimensions
Again.
is just a way of representing the numbers. Like you have like a bunch of numbers. You have a bunch of
So
words.
if you have a word, how do you represent that? How does the computer?
Let me do this. Let's try to represent this word. Let's do this. I have this is sad, but I want to represent in one dimension with ones and zeros. One dimension means that I'm going to have one vector of 1, another vector as 0, right? But how can I represent 3 words with 1 or 0? One word will be missing out. What I do, I add another dimension, right? So I can represent 1, 1, 0, 0, 0, 1, 1, 0. I can represent 4 words. But the vocabulary has, 100,000 words. Now I'm going to add dimensions to represent those guys. So this case, he says, okay, 384 dimensions is the thing that I'm comfortable with.
Well, 2 to whatever, like 2 to the 10th or whatever number of combinations, whatever.
Yes.
Using binary.
Yes. So that's how you pick the dimensions.
So question and a couple of follow-up questions. So the vector size is defined by the size of cross-figure dictionary that we take into consideration.
It's dependent on how you choose it. Spacey chose 384 dimensions to model their words, but literally.
Right. So that's point I think I or we could become kind of asking.
Yeah.
That how is that number arrived about the space?
So there are the LG model. It's funny this. I don't know why they picked 384, but I know that the large model has 300 dimensions.
And I think we are all looking at how they got that measurement has come about.
Well,
You choose that number. It's like, okay, so when you're building like so when you're building like a machine learning model, it's like how many like layers, how many neurons? It's something you choose, something you test for that. In this case, you can see 10,000 words are like through dimensionality reduction represent 200 dimensions. But you're right, like it's obviously like a very good question. How do you represent like why do you choose 384? But that's just something that the Spacey team tested and developed, and that's what you are going to do when you use a word vector.
Probably in some optimization, they had some loss function,
Yeah.
and the loss function said, okay, 384 is a good sweet spot for this model.
So that's a balance of efficiency and not losing fidelity.
Probably.
Right. So my
Probably.
follow-up question would be that let's say every year we add 1,000 words to the.
It has to change. The model has to change.
Vector size keep on improving year on year, changing year on year.
Well, that's a very good point because the Spacey SM model, actually the vector is 384. If you download the large model, It has 300 features. Sorry, no features. It has 300 dimensions. Why? That's a very good question. I don't know. But I'm going to look the next class. I'm going to come back to you with that.
So if you have this parabola over here, right? Now they probably tested, this is a link. If you think about how bad it is, right? This is like a measure of how bad the thing is that represent the number of dimensions is. This is the number of dimensions. This is how bad that like the cost, like how bad the representation is. So this could be like 400. This could be like 500. Then they're dotting down, and this could be like 100, and they're going. That's really bad. And now as you increase the dimensions, like wow, it's getting better and better until you reach this point called the global, or in this case, global minimum. The smallest, the least bad that it can be for the number of dimensions it has. And this sweet spot, like Vinicius said, is 300, whatever, like 84. Now you continue it up. Now it's over here, it's like 500. Now it's starting to get bad again. You choose this number because it's the least bad way of showing the data that they have. And they have like, I don't know how many words that they have chosen, but 384 dimensions is obviously very big, so it's a ton of words, therefore they needed to represent it in this manner. Otherwise they would have really bad representation. The context would be found.
So if this is the first dimension, could you look forward to
Probably, I don't think so.
It's not going to be more.
Whenever,
because the bigger you get, like 0, 0,
you get sparse matrix, and that this you're going to end up losing information on that.
how do you arrive at
That's the sweet spot.
This is so they tested. They started here at like 0 or like
look.
They started at 1 dimension. They went to 1,000 dimensions, right? Like I don't know what exactly they did, but I'm going with what like makes sense.
That's what I would.
Yeah. See, like you test. So
that's a hyperparameter optimization.
That's how you make your choices the best. It's not measured on actually how good you do. It's how less bad that you do. So whatever. So anyway, you start at 1 dimension, you go dot 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 dot, and then you go like 100 dimensions. 100 dimensions, not good.
Too much words, can't model it. Skip. 101 dot 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 dot. Now at 384, right? I'm just skipping some process so that it's like just testing each and every dimension. At 384, it's a okay, well, since it's good. We don't know if it's the lowest, but we think it's pretty good. So you have this point inside, and we continue on.
And then as you go on, like now you could at 500, right? The models, the vectors the word vectors getting really, really bad. So you know that, okay, it seems that 384 dimensions modeled it the best. So you want to model the best with the correct number of dimensions. And it's not something that you choose randomly. It doesn't like appear in your head. There's no statistical manner of deriving it. You test it out, you figure out how good it is. And this is actually how like all deep learning models run. You train. You start with a certain set of like numbers. They don't work, you choose better numbers and you go on. And this is the optimization that essentially all of deep learning runs on. So,
please.
Is it that there is a certain number of words and that's why it's that size? So for example, I was Googling, it says English has 107,000 words.
Yes.
According to But then when you times 384 by 384, you get 140 something. So I would assume there's 145,000 words in the model. Am I doing the correct understanding here?
I think I understand what you're saying, but the thing is, okay, you know what?
I don't think that they get the
384 is too complex right now. Let's look at 3D, right? Or 2D, right? It's just a coordinate plane. Your number, there's no limitations. Like you could go all the way up here, all the way down here. It's just a way of representing it.
Yes.
384, it's really tough to wrap the mind around, but this is what like the complexity of the data, like it's not like just simple multiplication because these axes can go to like negative infinity to positive infinity. And over here, negative infinity to positive infinity. So you can't do much.
So here you have the word to back with all the words. There are 71,000. So yeah, there are a bunch of words that are just left aside because the data that you grab to teach the words that exists, like a whole Wikipedia, doesn't have that many words.
Just 2 more things. You can see 1,024. Only 10,000 words, but 1,024 dimensions was the best way to model this data. And lastly, if this concept doesn't make 100% sense, like we'll be here a bit after, you can talk to us about it then, but also as the course goes on, it'll be more and more clear when we're training our own word vectors and we're setting our own dimensions. So it'll become easier to understand that.
Okay.
So far, so good.
All right. Now, since you like this technical part, make a disclosure here. We set this class to get into the Twitter analysis, to grab the tweets and render some visualizations and some information on that. Now, we're thinking about having the third class, a more technical class. So probably it's better for us next week to do that.
Yeah, I don't want to delve too much into the technical concepts here. We just obviously grazed over it, but I think we can.
Yes, we can do that next class. The technical part, the math behind it, I love it. So
we just want to get like cracking.
Yeah.
Get our hands.
No, but all questions are fair questions.
Obviously, yeah, of course.
So, okay, so another. I'm feeling blue. Okay, so okay, right. So now I put it here. Another sentence. I am sad. So we have this. I am feeling blue. The sky is blue. I am sad. Now enters the similarity between the documents. Spacey also has this similarity. So if you run this, you're going to have that documents 2 and 3. I'm feeling blue. And the sky is blue has a similarity of 0.52. While I am sad and I am feeling blue has a similarity of 0.83. So this is very important. On our third class, we're thinking about giving a class on recommendation systems. Now, if you can imagine, this is the core for a recommendation system. So whenever you enter, let's say, Netflix, and you have there 98% chance that you're going to like this movie. So their algorithm has two sides. One of the sides is this. They grab the features of the movie. There are some algorithms that actually grab the whole script of the movie and compares with other movies and see which movies are similar to the ones that you liked. And that's what they are going to recommend. It's a little bit more complicated, but is this. That's the.
So you can see here, the more, so like I just imagine this point, the more this distance is, the lower the similarity. The less this distance is, the higher the similarity. That's why you have a 0.84 similarity, because doc2 and doc4 are numerically closer to each other than doc2 and doc3 is, as represented by Spacey. So like this, closeness represents how similar these two terms are.
So it's some sort of a combination of vectors. I don't know if they have some importance for each word, each kind of word. I don't know if it is a stop word, it has a lower importance. I don't know. I'm going to deal with this, but I'm going to see that for you. But it's a combination, and each document is one vector, and then you see.
Human doesn't set these values. We don't. So when you train the machine, it identifies the words and vectors that need to be applied.
So you built this tool that.
You're asking about the input data. Is that what you're?
Yes, I'm asking how do you translate a word into the number? Like number could say 5.4 for the word I, 5.8 for the number.
Oh, that's the class number 3. We're going to do the model that we're going to input the data. We're going to put the one-hot encoding, and we're going to output a vector of numbers.
So not encoding, or is it?
So I understand if the numbers are far apart, then they are not similar.
Right. So what's the significance of the gotta be the -1?
-1 is just a position of the word in the document. Like 0 would be like I am feeling blue. -1 is blue. -1 is blue. It's just the index of it. So if you add like commas there, it's like.
So this distance is because your model, your deep learning, and the human labeling that learn from that. And if the human labeling has changed, say for example, in the context of an artist who is comparing colors, those two sentences are be very close. Blue, the sky is blue, or maybe the model, it comes from the human labeling deep learning models training. Because if you would define the context differently,
it's not human labeling.
It's not human labeling per se.
But human labeling was how the model gets trained by comparing the deep learning has to model it upon some human.
Okay, yeah, so the data set is, they grab the data set and see how words relate to each other. We can even give a class on predicting the next word.
That's a really big thing.
We can write a book on that. Actually, the algorithm understands what is the sequence of words. The algorithm doesn't have any idea how to write a book, but it understands the pattern of words. So it grabs this pattern and it outputs the next word, and it outputs the next word. So those numbers are probabilities of that being the next word.
And I think I completely understand what you're saying, because it's not like a deep learning model where like, oh, I am is related, like happy, whatever. You don't specifically define that happy is related, like is like, this like 1,2, whatever size it is. You don't do that. You actually just feed in this. A regular deep learning model, you feed it the input, you feed it like the Y, which is like the classified output where null it would be. But for this stuff, you just, X, cross that out. You only feed in this word set and it'll identify based on the context to find the
But the interesting thing is, if you trained your model to predict the next word, let's say that you are going to use all T.S. Eliot books. The algorithm will write in the same style because it was trained in the same style, the word that comes after another. Now, if it were to train with let's say, the Bible, the words are different. The way to put words, to put the sentences are different. You have a lot of inversions in the Bible, and actually a very different vocabulary. So the algorithm grabs this, this style, grabs the style where it was trained. So that's why we're saying that for each case, you have, it's nice if you were to have your own text, because your context, the art context, the finance context, you're different.
So you have a probabilistic linguistic model underneath it.
Yes, yes.
2 and 4 are similar. Yeah. So I changed that. I said, look, in the dog score, I changed it to something like I'm sad or I'm sexy. I'm always getting within the 80% back. So how do I interpret that?
Well, that's probably because the structure. I mean, if you look at this, dog 2 has the same I am. This has the same I am. It's probably because like the words are in the same, similar format to each other. That's why it's giving a high similarity. Whatever you put, like I'm sad, I'm happy, whatever. That's why that's happening. But like if you put like a radically different sentence, like I don't know, the sky is happy or the car is running good, it should give different.
One of the reasons could also be that both sentences relate to 80%. Rather than I am a boy or a girl, it's how we feel and feel. So it's going in.
And it's just where the words are modeled themselves. Like the car has nothing, like car and I are pretty different vectors itself. So that's why it's like the structure, I am, the first 2 words are very similar, therefore like it'll probably have a high similarity to each other.
Okay, I think this is going to be done.
Yeah.
Then this one is labeled. So now let's go to sentiment analysis. Now we can, you're going to have a class on how to do sentiment analysis, how to create sentiment analysis. But basically, you'll have beforehand some words and some linguistic studies that says, okay, exclamation point, exclamation mark after a negative word, it increases the negative sentiment of that sentence, etc. But Spacey doesn't do a very good job on that, actually. So TextBlob is the one that is better trained for sentiment analysis per se. And it has also this subjectivity vector. Now, so we used I am sad. So this is very subject. And it is a negative. The sentiment is negative 0.5.
It's a negative connotation. Like I am sad isn't really a positive state.
Okay, so it's very simple to get the sentiment of a given text. And why do we use that? Whenever that's what we are going to do here. But whenever you are trying to assess the public debate regarding a given topic, or any debate regarding a given topic, you're going to have people who are against, you're going to have people who are pro. And how do you grab who are against and who are pro? You use sentiments. This is a very good way to have a very good proxy on that. Now, that's what we're, okay, so just, I would like to just do one more thing. What we've shown you so far, using Spacey and using those tokens, are just, I don't know, 10% of everything that natural language processing has to offer, Spacey has to offer. So I highly encourage you to go over their website. And let me just show you, just let me.
Like one just basic example is, so you know how we said entities, right? Like NJ, like P, I'm just gonna write Princeton Public Library, how this is an organization, how this is a GP, geopolitical entity. Now, if you have like a completely different sentence, like maybe there's like this insurance surveyor who's checking out houses, and like living room, in the living room, there is like a sofa, right? You want to train your own entities. Like this stuff doesn't really match to what you have. And that's where your own training stuff is. You can create your own entities and you can train it. Use this label where it is and you train it. So now living room, identified as a room. Sofa, identified as a product. So like that's the point. You can train your own entities. And as I said, this is just, it's all up to you on how you use this code. And something doesn't like work out. There's new research that's going on like very recently. Top researchers in the AI field are constantly creating new applications for NLP. So the field is constantly enlarging. It's never stagnant.
So remember that we had that token example, which is New Jersey, MJ. So this is all the attributes. We used only ant ID. We use, I don't know, 5 of this. But these are all the attributes that this word has. So it's a lot of things. And we use all those features to extract the best information that we want for our case study.
Is ancestors is like if it's a root of the sentence. There's lemmatization. Lemmatization is really, this is actually a pretty good point. I'll just cover that really quickly.
Let's go. It's very important.
So you have, okay, I'll give a sentence. I am running. Now, what is the verb here is running, right? This is the verb, the action. I am running. Now, what is the infinitive of the verb? So like it's a fundamental to run. That is what the infinitive is. Now, in order to understand this concept, essentially useless. You really have no use of this ning starter. So for example, if you have I am starting, the ing is cut out, and like the suffixes which aren't really useful for your analysis are cut out. And lemmatization is really, there's stemming and there's lemmatization. They're really good, and there are some different algorithms here, but which gives you the root of the word. And most of the time, like one algorithm, for example, like it always gives a real word. Like it won't give like some weird word, but it'll take more time to process. But another algorithm, instead of like just cutting out the ning, may, for example, just cut out the ing. So now your word becomes R-U-N-N. So it's like the speed, what kind of algorithm you want to use, the popularity of the words. You have like pretty weird words, like then you really don't want to use the algorithm which just cuts stuff based on what it knows, but rather the algorithm which always gives a real word. So it's like some of the choices that you want to make while building your application and creating your own word vectors. This is a really, really important concept to cover. Any questions?
Guys, questions, please. Okay, comments.
You are going to start off by saying here are some things you should read. I thought you were going to suggest some material, so that we are not coming from different angles. Is there? Do you?
No, I don't have a bunch of material on that section.
Do you suggest that before you come to the next class, there is some baselining of skill set?
How hard do you think the class is right now?
It's not a question of hard. It's kind of slightly random, and it's not.
The class wasn't full at all. So what is the goal? We're driving knowledge, just the first understanding of which kind of information you can drive from text, And actually now the goal is, let's go inside Twitter, let's put a keyword that we're going to grab some tweets, and then we're going to assess what they're saying about this thing. So that's the goal. And why is this the goal? Because our goal here is to give you this understanding of how to use natural language processing in business contexts. And public debate is one possible business context. Next week, we were thinking about giving a prediction algorithm using NLP. So we were going to extract a bunch of information from texts, like reviews of restaurants in Reddit. We grab the reviews, we grab the number of stars, and let's see if we can make a model that is going to predict, based on the review, is going to predict how good the restaurant is, and even make some recommendations, maybe. This is another business context. So that's why the class wasn't the goal wasn't to show the mathematics behind it. It's just say, guys, and to be really honest, you don't need to know the mathematics. You don't. It's good, of course, but you just grab this information, you filter the data, the text, the way that you think, remove stop words, get sentiments, understand, okay, what people are saying. Those who think that the place is not good, what are they saying? Those who think the place is good, what are they saying? How do I filter place is not good or place is good? That's a question for you. Which thing I would use for that? Sentiment analysis. So I have the text. If the guy is making a bad review, I'm going to check the sentiment analysis. If it is negative, okay, this guy is not liking the restaurant. What is he saying about my food? What is he saying about my product? So that's the context that we're trying to bring.
And this
So you're trying to set the context in this class.
The goal, yes. Now we are going to enter Twitter, and then I built a class here, so you don't have to build this thing. I built it for you already, so you just copy this. The only thing you will need to do later is to build your own credentials, and then you can start playing with Twitter. Anything that is debated on Twitter, let's say Super Bowl, you can play. Let's say Donald Trump, if you like or not. I'm not going to enter into this, but you can check. You can check whatever you want.
Any like it'll scrape through and get the.
Please go ahead.
Hey, sorry, I came late, but trying to going through the documentation of Stacy in terms of the models they have, the web small, web medium, and large. So most of those models are based on CNN training models. Right? So I was wondering if Stacy has RNN models, pre-trained RNN models, because at least from what I understand or what my knowledge is, RNN outperforms CNN. So
that's not
necessarily.
No,
I mean,
I'm not.
It's
that's a very good debate.
It's really different, honestly, and based on your own choices, you really can train on. Like, all I want to let you know is Spacey isn't something that you should use all the time. Like, based on its like N core small, N core medium. It's really good for starting off, but when you're building your own business applications, you have your own specific data. You don't need data on like how New Jersey is doing if you're building something on like something totally unrelated. You want your own data. Therefore, the way you train and stuff like that, like you don't need to rely on Spacey, and you could use your own methods of training. And to answer your question about CNNs and RNNs, it's just types of neural networks, just something we're covering later. But CNN sometimes does actually outperform RNNs.
What does CNN stand for?
Convolutional neural network. So convolution, it's like, it just keeps on extracting features. Let's not delve into that right now, but it's a way of processing, reading the data, simplifying it, understanding it.
Okay, so now we are going to enter we're going to get tweets for a given keyword. I'm going to ask you to give me one keyword, but this is the class that grabs the information for you. Those who doesn't know how to build this kind of this class, just copy this. You're going to receive a bunch of information, but not all information. So you have it's 140 characters, right? So in those 140 characters, actually, the metadata, the whole database is simply huge. You have a bunch of information on that. You have the number of likes that the author has, the number of comments, the number of retweets. You have the whole, if I retweet your tweet, there's this information as well. So you have a whole trio of information. And I have that for the author. I'm going to show you what I'm saying. But you have a lot of data to work with, a lot of information. And also, I'm going to later I'm going to post the links for Spacey, for Twitter developers, so you can dive deeper. But here, what are we grabbing? We're grabbing the
API stuff. So like, as I said, don't worry about it too much. It's not the core stuff that we're covering. This is just using an API and getting data. And like, it's nothing to focus too much.
So what are we getting? We're getting the ID, we're getting the text, author, date, location, favorite count, user favorite count, user followers count, and user location. Why we get this information here from the users, from the user favorite count, etc. One, to see if the guy is an influencer. So this is something important. Is the guy talking about my product an influencer or not? And usually you have to pay for influencers to disclose their information. Is this rendering any output or not? So this grabs the whole thing. What you will have to do is set a Twitter account. That's the only thing you have to do. Now, you have to go to Twitter developers to set the API. And you're going to receive your consumer key, secret, access token, and token secrets. This here, those are mine. Of course, I'm going to change. But it's very simple. I'm going to post a video tomorrow on that. Actually, we do have a meetup page, School of AI, Princeton School of AI. I'm going to post everything there and also post on the meetup for the Princeton Public Library. And so I'm going to make a video on how to get those keys, this access. But so right now you can use mine. And actually you can search for any word. So which word would you like to search?
Like literally any word.
Any word.
Harmony.
Harmony? All right.
Harmony. Yep. Okay. Okay.
This is where pandas comes in, like the whole data frame. Like,
yes.
This is how we mentioned earlier at the beginning of the class, we're talking about the libraries to import, and this is like one of the staples. Like literally, basically all applications have this. You read data, you want to like analyze it, do stuff on it. Pandas is the way to go. PANDAS.
So it's already did online quick search on the entire tweets.
Yep.
What time frame?
Just enter Twitter. Just brought this information right now.
What data?
You can set everything. You can set the window. The bad news is the free account doesn't give you much access. So you can put a window, but it doesn't work that good. It works. I did a very interesting job for Flamengo, which is the soccer team. There's 32 million fans in Brazil. And I did a very good, very interesting Twitter analysis for them. As it is 30 million people, whenever I bring, I don't know, 10,000 tweets, it's a good sample. But Harmony, for example, this is the last tweet on the 7th right now. So it has a good frequency. But there are some words that simply doesn't appear once a week. So you need a larger database. Now, this service, you can pay for this, and you have access to the whole Twitter database, the whole historic Twitter database, or whatever. So you can do that.
Free account will only return some amount.
The free account
Limits their return.
Limits the return. I think it's 1,000 tweets every day or every 5 hours, something like that.
This prints
If
actually.
all of us are using your account, we're not going to. Can't do that.
No, I'm going to change it's just to show you this. I'm going to send a video showing how you can set your accounts. Well, enjoy right now my accounts. But
Everybody uses you. They lock you out.
but anyways, so that's the database. So we have the ID, we have the text, the author. Now author I'm going to show you soon. The date, location, favorite count, user favorite count. So this guy here, okay, this is a famous guy.
White City Cinema.
What?
They're
White City Cinema.
adding
No,
it.
it's adding.
Yeah,
White
it's
City.
adding.
Let's see the author who is. Okay, let's see the author. So okay, so this is the text. We're bringing the text and the author. So the text of this tweet is this. Is it because of bias or because black students are committing more crime? Now, name Harmony Ewing. That's why Harmony. So you have to check everything. That's why domain knowledge is important. You have to check for everything. You have to check for Harmony. You have to check.
Can you put one here just to find who did the 117,000?
Yes.
So this is just Python, like just going across her, right? Yeah, this is
Harmony Korine is the new American English.
Jim Gabriel. That is. Well, pretty famous person. Looks like 117,000. And
Is it a pretty rich API?
sorry.
Your API?
Yeah, it's
a lot of information. No,
whatever.
So Jim Gabriel is his name.
Like there's his tag, like in the
name.
Flip your face.
Flip your face.
That's such an interesting tag.
Okay.
Yeah, Jim Gabriel. All right.
Okay, so somewhere here is going to be this tweet.
Maybe we can just skip this page.
Yeah. Oh, you guys tweets a lot.
No. This guy.
I don't like tweets. I just have this account to.
And we're searching for
to
harmony.
check. But I'm really proud of this.
Microsoft built a Twitter bot, and it just
Look,
yeah.
I have one follow.
That's you?
Yeah.
That's yourself, right?
I don't have that. And the only post that I have is a professor said something about one school, and then I said, okay, so you're doing econometrics with only one observation. That's pretty smart. And then the whole discussion. I don't like this. So yeah, so we have the class. You have the class. You can grab and assess a bunch of information. And actually, now let's use a little bit of our knowledge to build on top of that. Now what this does, I'm going to create a new column called sentiments. So I'm going to grab the text and I'm going to check the sentiment of the text. And also the subjectivity. So, okay, now we have the same database, but now we have the sentiments. You see? So now we are starting to use everything that we discussed to actually drive some knowledge, to drive some information on the things that we care. So it's pretty funny because so far, I don't know the feeling for you guys. I like studying machine learning a lot. But without looking at the data, without applying this to some information and seeing, that's so dull. We just said, oh, how do you do this? But now we are getting somewhere. We are extracting some information from the text. So yes, now you can separate those who are saying something positive regarding harmony, those who are saying something negative, which I doubt someone has said something negative about harmony. Those who are more objective regarding something or more subjective, etc. Now we can start to assess what the customer is talking about us.
So, sorry, so how did you do that? If you look at those numbers, how are you deciding?
That's a fantastic question. Now, everything will depend on your threshold, and that's something that is only up to you. Let's grab Amazon reviews. You can do that for Amazon reviews. Oh, we're going to do that for Reddit. But those who comment on Amazon, Airbnb, those who comment on Airbnb are those who loved the place or those who hated the place. Those in between are not going to say anything. And of course that the sentiment is going to grab this. You're going to have people very positive and very negative, but maybe the thing that you want is in between. You want the fair analysis will be on the guy who's between, I don't know, minus 0.4 and plus 0.4. The plus, but of course you have to check the plus one and the minus one, because the minus one is going to say, that's terrible. That's minus one. So now it depends from where on your case. You're going to set, you're going to check. That's for the capstone. The capstone.
So the fact that there's no negative out here means everybody is positive about harmony. In this list that you have out there.
In this list, we can check, I don't know, Venezuela. Nowadays. Venezuela maybe is going to.
It will have some negative sentiment.
But harmony is pretty. We can put. Let's put Trump, and then we're going to see now we're going to see some division. So that's where we start to we can start to play with this kind of thing. Now, all right.
So you can have all these tables and this fancy code and stuff like that. What does it mean? Like, how do I understand this? And this word cloud, which is pretty famous, it's like you understand what words are trending, what words are popular, and it's actually a really common way of understanding, visualizing this stuff, what words really do matter in this context. So as you said, say not even positive, just purely negative IMDb reviews or whatever reviews. Bad would probably be a big word, right? And then quality, maybe another big word. So the point is, what words matter is displayed by this word cloud, and we're using this thing called matplotlib, which is just a library for perfect visualizations. Really, really quick one right now.
Yeah. So the size of the word represents the intensity that it appears in a given text. Of course, here I did this. We did this word cloud on only one text. So here we are going to use. We're going to grab. Yeah, so that's a text pro. Text pro, what I did, I said, okay, give me the data where the sentiment is positive. And now let's put the word cloud. And now let's see what words are related to harmony.
Perfect.
So now you start to have some knowledge. But of course that you would have RT. What is RT? Retweet. So we have to clean. Retweet doesn't mean anything, but it is on the text. So, now here's for now. Okay, let's see this. That's for negative.
Yep.
What?
No, we use a different word, harmony. Therefore, the negatives are.
What's
No, this is actually. So actually, you know what? This attacked HTTPS. That's pretty negative. Our data, harmony, is not really that common of a word that people use in tweets. Actually, this is it's actually based on a TV show, Nation Attacked, Fire Nation. That's all off the TV show. That's why.
Yeah.
And they use the airbender or whatever.
Okay.
But
so now what you have to do actually is clean this text. In our case, remember the stop words. So before I was using wall. Was harmony. Okay, now let's see. Now the idea is I'm adding to my stop words. I'm adding the word RT and harmony. Sometimes you're going to see. And let me see if I'm doing something else. No, that's the only thing. Now, this is the part right here. This is the part where you get to clean your data. But actually, sometimes you just want to see if you just want to check the adjectives. Remember that we saw before that if you put ants, you're going to have if it is an adjective or not, if it is a pronoun, what it is. Maybe you just want to grab those kind of features. And then you just add here. You're going to for loop, I'm for looping in every single word. And I'm going to check this word is an adjective or not. Is this word a stop word or not? Is this word is something that I want? And from where do we get what we want? From spacing. From that natural language processing that we were doing before. Okay, you had a question.
Yeah, I was wondering, can you explain the for loop there, if, else, there, will?
Yes.
Especially the else.
Yes. Okay, so to build this word cloud, what I have to input a text, but I want to give as an input all the texts that I have that are negative or positive with the filter that I want to do. So what I'm doing, I'm creating a whole text. So here, full text equals empty. That's an empty string. Now I'm going to add every single word that, if it is a stop word, I'm going to pass. If it is not, else. If it is not, I'm going to add to my text. So let's say that harmony, before we filtered harmony. Harmony was going to appear several times and was entering here several times. So I have a full text of every single tweet that is positive or negative. And then this full text, I'm going to put in this thing here to make this word cloud, and so we can understand what they're saying. Okay?
Yeah, thank you. This is where you also introduce lemmatization if you want.
Yes, that's a fantastic point. Very good point. So whenever you are doing this, let's say the word that is more frequent, it appears bigger. So let's say that I'm doing Nike, and you have runner, run, running. Those are the same words. That's run. So whenever you put lemma underscore, running, runner, everything will be run. And instead of appearing running small, run small, etc., it will understand everything. Run is going to be big. And this is something very important for Nike.
The color also represents something?
No,
I think the color is just look at
just beautiful.
Anyway, one important concept here is we understand running, runner, basically all the same general idea of run, but to a computer, numbers. So yes, while it could determine by context, why do we need to introduce more possibilities for error when we can just cut the er, the ing, all that down into the same exact word, which is just that one word which we actually need, because everything else is just like you're creating multiple associations for one word. If you can like follow the drift of what I'm saying, it's just one word, but it's just because it has an extra suffix, computer thinks it's a completely different word. And yes, probably like its similarities are going to be pretty high considering they're going to be used in the same context. But there's a big problem that you don't want to introduce more sources of error, more opportunities for the model to go wrong. So that's why we're doing standardization. It's pretty low.
Okay, so now I have the text positive. Now let's see. Not a very negative feedback. Wrong.
No, you have an underscore there. Still have the underscore.
Where?
Okay, never mind, we're good.
Okay. I take it the proximity of the words in the cloud doesn't mean anything either.
Yeah.
No.
Yeah, it's just way of organizing it. Like I think the only main point is like how.
Now, what in that function, what we did was to filter out RT and harmony, right? Because they were appearing very big.
We had RT is like a useless word. Nobody really cares about RT.
Here, RT and harmony. But then those words doesn't give you any more information to your context. So we filter out, and that's
it was RT,
the result.
true intelligent, and true.
Pandit it's not recognizing it in the same word, rather than it's kind of duplicating it 3 places. Pandit family.
Well, so
I mean, they're different things, right? There's 100 families, low funded.
So this is the kind of thing that you're going to, by hand, see those trends, understand, first of all, I need to understand what's pendant. Why people are saying pendant with harmony. So that's where the information, whenever you are a decision maker,
right,
you're going to look at this, say, the data scientist is going to present this. Probably he's going to do some other things, but it's like this. And then now the decision maker is going to grab this and say, okay, no, okay, pendant, that's important. What is this? Oh, yes, that's really important. Or no, that's not important. Leave it aside. So you filter out. Just filter. Everything that you think that you don't need, filter. And then you're going to grab the information that is important. It's going to pop up. So like the Flamengo example, my soccer team. It's a soccer team. So probably you imagine you have a bunch of curses, you have a bunch of the fans cheering, putting the things that we sing in the stadium, etc. Filter everything just to grab the political sentiment regarding the team. In our case, we wanted the political sentiment. So that's the way that you're going to filter this is up to is case by case. But how you're going to filter this, we've shown before. You grab the attributes, you're going to see the attributes of each token. If this attribute is not something that you want, filter. So that's why that's why we present it like this. We showed, okay, that's what we are going to extract from text, but now let's see hands-on. What would it look like?
Yeah, I had a quick question. So there's a fine line between fudging the data and using your business knowledge to figure out data. How do you draw that out?
What's the first option?
Fudge. I mean, you're just basically removing the sentiments that you don't like. So let's say I'm a consultant.
No. That's a very tricky point. Yes. Yeah. No. That's very important. Very important.
How do you?
Because if you are a consultant, there are two guys, the good and the bad consultant. If you are a good consultant, which that's what I do actually, I present to the guy. Say, okay, this is the first result. The first result has retweet, etc. Now I then say, okay, I eliminated these words. Retweet, eliminate this. Why? Because usually this appears in every single tweet. I have links here. Now links is something that I deal with it in another word cloud, because usually are important websites related. So that's I deal with that in a different way. But I present everything to the client. Why? But that's the most important thing regarding AI. Domain knowledge is the most important thing. It's not the AI itself. Of course, it helps. Of course, it's a lot of things. But without having this knowledge, for example, I'm not an English native. Pendant, for me, I have absolutely no idea what is pendant. You're not native.
It's a word, means a scholar, and also family name in India.
Okay. I had no idea.
It's also used in English, but it's by the way, when people talk about pundits on certain concepts.
But like pundit is with you or with a? If the guy is pundit.
It's just how you spell it, yeah.
As much as it's a word.
No. So pundit, but I thought that pundit would be with you instead of a.
Yeah, it's just different spellings of the same thing.
Okay. In English, as an expert, you use the you rather than
okay. So yeah, so that's the point. You need the domain knowledge. You need to know what you're talking about. Otherwise, it's just a bunch of words in a beautiful way to display. So that's the place.
Can you go back to the similarities? Well, can I assume that it's between 0 and 1, where 1 is a perfect correlation?
Minus 1 to 1.
Minus 1.
Minus 1 to the 1.
Minus 1.
So cosine similarity.
I see.
Okay. Guys, of course, that what I've shown here are word clouds. They are a little bit tricky to make. Actually, they're easy, but not a lot of people use that. And actually, we should, because it brings a lot of value to your customer or to your business. But of course, you can make histograms. Let's say the sentiment analysis. Let's make a histogram of sentiment analysis. let's make it up. You can do a bunch of things of that. We can be here, I don't know, for 3 days, just doing some visualization on every single aspect. Now, we are wrapping up, but what, do you want to say something?
No, please go ahead.
What I would like to propose to you is, you have the code. I'm going to show the video of how to get those Twitter access, and play with some words just to check. Let's play with some debates. I'm going to send you. I think that they have an English version of that, but we had a very interesting visual. Let me show you. We have 20 minutes. Let me show you that. You're going to like this. Right. Now that's the polarization on the political spectrum in Brazil. So this is the PT. It's the left-wing party, the left-wing debate, the right-wing debate, and the guys who can, or they are making the bridge of the communication, or they swing to one side and to the other side. So, to be really honest, now you have the tools to do things like that. Swing states here in US, what are they saying? You can do this. Of course, this visualization.
It's pretty difficult. It
But-
looks really cool.
But you can. That's very simple to understand. And actually, what do you do? Let me ask you something. Why do you think these guys here are in this hands? What is the metrics that we learned that define these guys here? Sentiment. Those guys here, sentiment. So that's the point. We have the tools to make it very interesting, to drive interesting knowledge for the debate. Well, I like political debate, but actually you can do that for your soccer team, probably a few of you, but
football team, whatever. Just football
team.
What is the top down? The left side is sentiment. What do you put in the top down?
The top-down dimension is to look beautiful. Of course.
Because some of the things are like, up above.
Look, what it says is that 60% of the different profiles manifested support to Lula, our former president, or Bolsonaro, our current president. 70% is those guys who are very favorite to Lula, while 19% is very related to Bolsonaro. So for the first time in our country, a guy who is a little bit to the right has more, how do I say this? It's the density of
leverage.
Has a little bit more leverage than the left guy.
So these are like the insights that you can derive from the NLP applications that we're creating with the Twitter.
This is a whole. But actually, you have the whole report. Oh, this is this week report. Yeah, okay, of course, it's a bait. So that's the point. I think that the goal. Now I would like to ask you honestly. The goal. Our goal here is to give you tools to have access to different knowledge that usually you do have using AI. Now, from this class, do you think that you leave here with a little bit more access to tools to assess debate or assess something? Yes? Okay, so please, questions?
Are you going to put the code in a GitHub?
I can put the code, yes, definitely. Yeah. And actually, we are recording.
Yep, so if you have any questions, you can just...
We're going to give references of what we can read.
I'm going to give a lot of references. A lot of them.
If you have
Don't
some specific
worry.
questions, you can look at the person who actually created the School of AI. So Roger Wall, written down here.
That's the first reference.
Yeah, so like if this is the person who created the main organization, we're just one of the sub branches. He has absolutely wonderful videos on the topics that we're talking about, more topics, and if you want to go deeper, the math behind some of this. So it's really just an interesting watch.
Oh, no. That's very interesting. Look, he just released this video. Of course, I'm not going to show the video, but I'm going to show you. Looking good, man. Okay, that's the one. Machine learning with no coding. So, actually, in this video, he shows how to. That's more or less what we're going to do, but that's the whole idea of how to bring business into your daily life. There's another reference that I'm going to give you, which is Andrew Ng. And this guy is simply fantastic, and he just released a very good. What's the name of the?
I know what you're talking about. Like, it's actually very recent. I think it started this month only. Like.
Yes, no, it's fantastic.
Yeah.
7-hour course on how to do deep learning.
It's like Kickstart machine learning. I don't know the name of the course.
Okay, that's the one. AI for everyone.
Yep.
Now, what is AI? Building AI projects. Now, 1 hour to complete, right? 2 hours to complete. Building AI in your company, AI in society. So it's a debate / everything you know about AI without need to code. How to put AI in your business.
It's really
how to do consultancy. Yes, please.
First is that and he also has
Yes.
the best upgrade.
The deep learning, yes. I'm going to give you every single reference that I know.
Yeah, he actually.
We can compile a list, like a big list, like I'm talking on GitHub.
Yes.
And like README and like links to everything.
I have a text comparing. I have that when he released the deep learning. The deep learning that I was one of the first to finish. I was crazy about it. I was here at this library studying like crazy, and I wrote a text on LinkedIn. And actually, 1 week before that, or 2 weeks before he launched that, Siraj launched a series called The Math of AI.
Yep.
So I did The Math of AI, and then he released that course. That's why I did so quickly, because I already knew. But his course is I'm not going to say better, but he explains more.
The language uses Octave, and it's not Python, but it's it's not what we're doing. It's actually a bit more complicated than that. But Octave is it's pretty good. That it's really easy to you deal with the vectors by hand. Like whatever vector math we're talking about, you deal with those. You find like the dot product. You do multiply matrices. You do optimization algorithms. It's really good. The
linear algebra. He uses only linear algebra without using those packages. Only later he's going to use packages. The rest, linear algebra. So you can understand which vector is entering where, what's happening, this goes here, this goes here. If you want, that's a different goal. And I think that's the point. If you want to start to code and develop algorithms, you should start with this course, definitely. If you want to, I have a good friend who's working in São Paulo, and he's doing pretty well, really well. And he said, "No, Vinicius, you know what? I don't want to program that intensive. I don't want to know what's happening behind, because I don't want to program sentiment analysis. I just put .sentiments and it renders me. So I'm not going to lose time on this. I want to sell."
Okay, I have a question for you before we run out of time. I'm just curious if
I think she may have left Jack.
Yeah. So my question is this: it seems like it's a fairly diverse crowd here. It would be great if there was a way to send people an email. My question is, if we sent you an email and even asked you 3 questions, what are the top 3 things that you would like to understand about whatever?
Like a survey?
What would be your goal for?
We can do a survey.
Yeah, we were talking.
You'll have your email there.
I'm putting yours right now.
Okay. Yeah, so enter the meetup group, by the way. subscribe there, Princeton School of AI. We're going to put some.
Your work back, make an example of it.
Yeah,
Text
yeah. Oh, that's a very good point.
That comes out. You know, the hard part of doing this is actually getting data. It's the computer, the button on which algorithm. Pretty cool. So, and then of course the back end interpreting. But it would be an interesting, very simple example. And it would be, the application would be: are there vectors, clusters, whatever, of similar interests, and how big are they? Right? How many people want to do this? How many people want to do that? How many people belong to different?
But can I do it just so we can prepare for next week's meeting? First of all, well, I'm not doing class this being polite, but so next meeting we can do one of two, or we can enter into more technical stuff, or we can grab reviews from Reddit, make a proper cleaning, and make a prediction of how many stars that review will render in a restaurant or something like that. Who would prefer the second one? The first one is the mathematics.
First is technical. Second is building a hands-on application.
Okay, let's see. So, okay, first one. Math. Okay.
You're gonna teach
Just
No, it's like the math. I mean, linear algebra itself is a pretty basic concept, but how it specifically is applied to computing optimization, the one that I talked about here, finding the distance between those 2 points and then interdimensional
Let's do both. Yeah, I think you should give some high level concept of the math. You don't have to go deep in, so that way we apply, you know what you're applying to. Otherwise,
I'm going to make another proposal. We are doing this course. We have a computer vision on April.
Yep.
And then on May, if we get good reviews, I hope that we get, we would give recommendations. Time series.
Yeah.
Time series. It would be interesting. And then a recommendation system, and then time series. But what we could do as well is to put this class as business class and start. Would love that, a mathematical.
Just out of curiosity, who here is interested in doing the capstone project, like the final end of
Yes.
the semester project? Capstone is like, so we teach all this stuff about NLP. You guys build your own application on what you want to do, and we'll help out with whatever we can. So it's like, we're teaching all this stuff that's like yada yada yada, like feeling back. So that's a good number. So
it's okay. So yeah, so the fourth. We're going to always end with a capstone project.
Yeah.
So the last week is we're going to get together and see how the capstone project is going. And actually, you can email me, Cash App during the process, so we can discuss. I'm doing this, what do you think?
We can create like a central messaging system if need be. Like I think Meetup itself has its own discussion board, and that's pretty good.
So yeah. Any questions? Yes, please. Go.
Yes, sorry. So where do I get this notebook? How to access that notebook?
It's on the I can do it.
Sorry, no. We're going to put this on GitHub. You are in our meetup group.
Yeah.
Okay, so we're going to put.
There's going to be a blast post today.
But there are two meetup groups.
So I signed up for code for Princeton. I didn't sign up for it.
Yeah, so there's the School of AI. That's the one that we can control.
Okay.
We can put stuff. And
did you say that you have a website as well?
No, our meetup is our main thing.
Yes, Princeton School of AI. Yes. And so we're going to put I'm going to put the references. We're going to put this code. We're going to create a GitHub account for Princeton School of AI. We're going to push everything, and also the video. If 2-hour video,
yeah, I don't know who would be interested in watching 2 hours, but like 2 hours worth of content.
And please, I'm going to shoot a video on that. I'm going to put this video tomorrow.
Well, just one point. While we're creating the applications, it's like it's really simple. You just grab Twitter data and stuff like that. But it's also like a real pain to process the data when you're taking even not even NLP. In computer vision, it's more of a big deal. You take an image, you need to cut it down exactly 256 by 256 or whatever size you're using. And that's why I was emphasizing data structures and like analyzing data properly, because you need those good practices in order to actually apply it to other real world applications from NLP. Because it's like image is like n amount of pixels, right? You need to properly find the face, cut it down, and stuff that I wanted to go over in the next module.
Dealing with the database is 80% of your time.
Really, yeah.
At least. So it's always a pain.
Pre-processing, looking at the data, extracting it. Finding the data for that matter, you just don't easily just, if you're building something like niche, you don't just get the data randomly. Like you either need to collect it or like go through some obscure website. So it's an entire process.
Most people use Python for all this AI work, or is there other languages?
Python is most clearly used, but there's also deep learning for Java if you want to. Like if you're feeling more
Java for deep learning.
DL4J, it's like a thing.
I think Python.
It seems like there are a lot of libraries in Python.
You'll have also a lot of people using R. Those who are statisticians use R, and you have nowadays Keras and etc. for R. But if you do you know R?
No.
So go with Python. Yeah.
No, Python is more English than R is.
Yeah. There's also I've just looked it up. There's a spacey library for R as well. So
if anybody uses R, I truly recommend going to Python. But I started programming with in R. Then I migrated to Python. Now I'm going back. I had to do some stuff in R again, and now I can say building classes, for example. This is something that in R doesn't exist. In R is going to be a bunch of functions, but the concepts. It's not an object-oriented programming language.
Does anybody need this information still? Like the emails, the meetup, the guy who created this stuff, and our goal?
The email will be in the meetup site as well?
We'll put that in the
Yes.
Thank you.
Yep.
Right. Guys, thank you very much.
Thank you so much for
You know the good thing about having a full class? Because the guys on the front are a little bit ashamed of leaving. Then they stay here and everybody stays here. No, if you need help, it's not only this class. I just canceled a trip, so I'm here. Whenever I do have a business, but right here, right now, I decided to separate things. And later, are you just subscribe to our meetup? If you contact me there, you can. And actually, I'm LinkedIn, Vinicius Pantoja. But we can talk.
Is there a certain type of database you guys look for? Program this might
that's a question. You used to call it CSV.
If
you think
that's a little bit tricky. That's depending on the if it is on Twitter. That's
But whatever database you use,
if it is on a website, it's pretty easy to do as well.
Spark too.
But if it is on Facebook,
So is pretty hard to over their own Spark.
No,
I think there's like a Spark
to get information.
For example, sometimes so that would be possible. Thanks.
It is. Pretty straight. Thank you very much. Please get in contact. Whatever you need.
Of course, notebook. Add these statements into run the cloud. Is it because I didn't run these before?
Yes, in the top
I gotta run
you have to run this. And now you imported everything. No, you don't need to run this.
But then the other problem was even three were not different. So I had to run this.
Yes, you have to run
Because it has to load it in memory. This is all one session.
But after 15 minutes, it stops running.
Yeah.
And then I think it erases everything. So you have to run again.
So what is Jupyter? Is it,
Jupyter Notebook is one type of visualization of the program. I can show you other things. I use Atom a lot. But there is also Spider.
He's recording.
So there are different ways to visualize what you're writing in Python.
Oh, just Python. This is Python based on.
No, actually, you can have Jupyter for R. I can show you.
And it shows the output also.
It shows the yes, it shows the output. Jupyter Notebook is good to make this kind of presentation because it shows the output beautifully. So you have a sequence, and then shows the output. Jupyter Notebook.
Each one is a block.
Each one, but they are not.
How do I get? If I wanted this all in just one file.
No, that's one file. That's one file.
And what if I want everything without this stuff?
You have other things just like grab Spider. Spider is very good. First, download Anaconda. Okay, let's do this. You should have that's more because it's important. To download Anaconda, and then to how to use Spider and Jupyter.
You are already getting this.
That's
a lot of good things.
Ah, you put Trump. No. Yes, that's.
This is local. This is face to face. So I can talk with you. That is online.
You put it in stop word. Oh yes. Where were you?
Learning from where I learned from the guy from Roger's
Keyword center.
and Andrew.
Okay. Because I haven't run this because it has to have the column setting. So let's see.
Okay. So I was wondering, can you
I don't know. That's a good point. I don't know. Because I think Google Glass is a right format.
Yes, every single one should be there.
So hi, so very good. I mean, really good class. Thank
Did
you
you
very
like
much.
it?
I like it. Serious. So very good. I mean, finally, I find a really good group that can really show something about those really technical. I mean, coding everything.
It is hard, right?
It is. So
I promise you that I was trying to do as simple as possible.
First depends on the audience. I think the first one.
These guys, there is a guy over there called Bala. He's very good. The guy who showed up later.
Oh, okay.
He said, I showed up later, where I can get this code. I remember 2 years ago going to a meetup. When I got into US, I went to this meetup.
Right.
And he said, no, here, this is a small project that I did. I said, whoa, that's cool. I said, everything is on GitHub. Then I entered the GitHub to copy. I couldn't copy. Because the thing was very complicated. Financial markets.
So that's why I mean, I suggest put in a GitHub maybe who are interested in geocode, put something in there and then you exchange it, something like that. That's the place. So it is a start point. I mean, people you can
That's
share
true.
with
That's
them.
true. Oh, I think that we have a very good problem.
Right.
And actually, we can we have some hackathons. We have a bunch of things going on that are in the public in different levels.
Right.
So it's just a matter of time before people getting together and say, okay, no, let's do this group here, this one group here, this one group here.
It really depends on the audience. I think they have a different level of knowledge and interesting and experience. So that's why I think it's really stop point. I mean, a really good class. Thank you very much. So how do you contact? I mean, in the email,
Meetup at the meetup is going to have our email, and then shoot me an email in here,
Okay.
not going to travel anymore. I was going to Thailand.
I know, yeah. Wow, nice. Okay, thank you very much. See you next time. All right, thank you.
Um,
Thank you very much.
Yeah, so I told you that was going to, but so it wasn't. Okay, I'm going to give you some very good references. And no, I'm going to give you good references. And so starting tomorrow, but the hardest thing to find is someone who's going to help you. And I was very fortunate to call on a very good friend my time, and then you can call me. Grab my email on a meetup, the meetup group, and Princeton School of AI. I'm going to post my email there, and then I'm going to give you the references. And whatever doubt you have, just text me saying, I'm trying to do this. Here's my code. I'm going to do this, and this. Okay?
Correct. Thank you.
Imagine,
Yeah, let's see.
Happy
Good.
to see this is, back together.
Yes, I'm so happy to see you here. I saw you enter. Oh, that's so nice.
If you guys, if you guys need any help,
We will actually. We will because no, that's the point. I think we have a huge class, and I think that next class. No, actually, I'm going to talk to Cash App. How are we going to set this up? But we have people with a very who needs help in some more in programming sense. Though there are those with needs on other sense. Let's do it together.
Yeah,
Let's do it together. I'm going to contact you.
yeah, I will. I'll give you a email. Just say
You can do fundamental point stuff. Like, do you understand what I'm trying to say?
Yeah, no,
You
like
can do like
this.
fundamental
Going to
distance.
Thailand,
Yeah,
Yeah, that's fine. I'm just saying, I understand all that.
I was going to arrive in Phuket.
But then, like, these numbers. I'm just curious.
To be honest,
it's so this is a regular deep learning model.
something $25 or $35 an hour. Like, this is magnificent. He's going to be redoing my basement, and he just came back from 4 months in Thailand, and he earns it. He's very
It's
nice.
very
I can give you the
I personally am
information.
not an expert in how.
Okay.
His name is Tim.
I'm going to talk with my wife.
My neighbor is going to go to Phuket next year in December, I think.
I had tickets bought for
I would say I would
Wednesday,
research shoot.
but because of the class, so then I said to my wife, look, because I bought these tickets on Black Friday.
As far as
$400.
Oh, round trip.
Really, round trip. $400 to Thailand, to Phuket, directly to Phuket. I wasn't even going to Bangkok.
And he's right in the middle of the island. I can send you pictures.
So, I mean, that's one thing.
I'll ask him.
All right.
Yeah, but that's it's pretty interesting. So I guess next week you guys will talk more about the
No, we are going to do this for sure.
Yeah, and any help? Is there any like main like frameworks that we're gonna like revolve around, or like TensorFlow, Keras? I mean, I just think Keras would be.
We would use yes.
I mean, it's not the industry standard, but we could also like introduce fast.ai.
Okay.
We can. No,
Yeah.
so I see that you and Cash App wants to go this direction. I like the math behind it.
I mean, don't get me wrong, I love the math behind it.
No.
but, like,
The point. What I'm saying is, I think that we can build a larger. We don't have to have one meet.
Yeah.
We can have just like a school.
Yeah.
We can have classes, different classes running at the same time.
Yeah.
I do.
We have to talk.
Do you like that?
Yes.
So yeah, I think.
I'm going to talk to Cash App.
You're very
Let's
advanced.
arrange this.
Okay.
Thank you very much.
Thank you so much.
Thank you very much.
If you and I can send you an email or something if you want like my
Not much
contact
recently
info.
because of school stuff.
No, but I do have your contact at the
do you
meetup.
really?
Yes, of course I do. No?
I don't know.
No, I do. You were in our first meetup.
Yeah, I was on
You
the
gave
first
the
meetup.
email, right?
Yeah, I gave the email, but
Yes.
I just didn't know. Like,
No, I have.
Okay, what's my name?
Adam.
Oh wow. Wait, did you listen when I was talking to?
I knew that it was Adam.
I teach myself.
You came to
I didn't get
the Python program.
Yeah.
And then I looked you up.
Yeah, sorry, I
Now I
didn't.
understand the theoretical aspect. Like,
pay attention to that or this.
You were sitting over there.
Yeah, I didn't pay attention to that one or this one.
That's
because,
good.
Thank you.
I don't
How long
think
did it
I
take
eat it too much. But I don't know, I just like to come for.
But this one, did you like or not?
I definitely liked it. Like I still thought it was a bit rudimentary, just because like
It was. It was. If you know NLP,
yeah,
it was.
just because of like what I do. But, yeah.
What do you do?
Well,
okay, that's
oh well, actually, I was one of the School of AI Fellows. If you like kept up with Suraj's videos, he like did like a fellowship or
yes.
There we go.
Are you a fellow?
Yeah.
Oh, congratulations.
Yeah. Yeah. My project was I did teacher evaluation with dynamic memory networks.
Caramba.
So.
Caramba is wall in Portuguese.
You say, I don't mind. But yeah, I did dynamic memory networks to try to do teacher evaluation.
No, I'm not working.
So that was fun. That was like the most like
I do internship.
NLP that I did. Right now, I recently got a telodrome,
With
and I
him,
want to
so
use
we
like
both applied to become a
reinforcement
dean
learning to try to like
and
make it
like I
file
think
its
multiple
own.
people applied to local subject.
So yeah, I'm using the
yeah.
curiosity, large scale curiosity driven learning.
That's very important.
Yeah, 'cause I think I don't know. I think reinforcement learning is like super cool.
It is.
But I think it's not right now. It's not too much functionality outside of like research. Yes.
My wife is doing her research. And she's doing reinforcement learning to make predictions of where to search.
Yeah, it is. But like for larger, I honestly think for a larger like audience, it's not quite there yet.
No,
So
no, no.
you don't work
Still
with
super cool.
No, I will. Let's all. We're going to get together. We're going to do this. We're going to have a business class. We have to do this. And he was really good.
really advanced.
He was a fellow on a Suraj fellow.
Really?
I mean, he has a
On
long
what
history.
Suraj, that guy Suraj Raval, that
The guy who
the guy.
over there.
You're going to know the information.
I got $1,000 in Google Cloud credits for free.
Well, what did you do recently?
It was I wanted to evaluate how good a teacher is. Based on like
Based on what?
So I used dynamic memory networks that was originally
Oh, sorry. Thank you so much.
that originally was